In this video, we present to you the content of subsection B3, Requirement Engineering in Software Product Line Engineering. The aim of this subsection is to provide a well-structured platform that supports, improves, and expedites requirement reuse in software product line engineering. Our proposed framework, Requirement Patterns for Software Product Family, identifies 5 key concepts in which requirement patterns can contribute extraordinarily to requirement engineering for software product line engineering. These include the following. 1. Reusable structure, prospective development. Patterns has been defined as a regular way in which something is done, thus provides a tangible solution for a recurring problem. In the same manner, requirement patterns provide a structure for solving recurring requirement engineering problem. In contrast with opportunistic reuse, when reuse is planned beforehand, a systematic reuse is achieved in the end. 2. Scoping and requirement engineering. In software product line engineering, scoping is a method used to define the prospective products in the software product line and their main features. Commonality and variability analysis are part of scoping and requirement engineering of the product line. Interrelation between product management and domain requirement engineering is challenging, especially during decisions on product scoping and validation on common and variable requirements. Requirement patterns provide a design for the use structure, thus minimizing the complexity on the decision-making on common and variable requirements. During application engineering, it also provides design with reuse structure, which facilitates smooth derivation of software requirement document for individual application. Third, intertwining of requirement engineering and design. In software product line engineering, the inputs of design sub-process are the requirements defined in the domain requirement engineering and the variability model. Clarity of these requirements is of utmost importance for the product line reference architecture. The interrelation between the requirements and the architecture is described as a twin peaks model in the literature. In this case, when requirements are defined to be too ambitious for the architecture, modification of these requirements is required, and this is tedious. Requirement pattern for software product family proposes a flexible structure for common and variable requirements, as well as variability model to be intertwined smoothly between domain requirement engineering and domain design. 4. Traceability, impact of requirement changes. Traceability of requirements artifacts between domain and application engineering and software product line engineering is indispensable. In fact, creating a traceability links to requirements artifact in both domain and application engineering supports the subsequent reuse of domain artifacts in the application design, application realization, and application testing sub-processes. However, traceability in software product line is cumbersome, especially if the scope is too broad. This research identifies that requirement pattern provides a flexible structure for reused and with reuse, in which traceability of requirement artifacts in domain and application engineering is done easily. Finally, but not the least, variability. Variability management is an essential activity commences at the initial stage of software product line engineering. This stage is called product management subprocess. The variability artifacts defined in domain requirement engineering are refined in the subsequent subprocesses and furthermore bound with application artifacts. Due to large number of stakeholders introducing many internal variabilities, complexity of the variability pyramids increases with time. Research shows that explicit documentation of variability improves three main keys. 1. Decision making, 2. Communication, and 3. Traceability. Requirement patterns provide explicit documentation template for specifying requirements. You can now proceed and answer question number 3, 4, 5, 6, and 7. Thank you.